In this video, we'll explore how to find absolute extrema. This is also called finding global extrema, and instead of extrema, we can call them maximum or minimum of a function. So absolute max, absolute min, global max, global min of a function. What a global or absolute extrema is it's the absolute highest point or lowest point of a function over its entire domain. So the absolute max would be the absolute highest y value of a function over its domain, and the absolute minimum would be the absolute lowest value of the function over the entire domain of the function. So let's start off by looking at an example. So in this funky graph that I drew, we see that the function is only defined between x being negative 1, 2, 3, negative 3 to 1 to positive 3. So the domain of our function in this example is from negative 3 to positive 3. So when we talk about finding the global extrema or absolute extrema of this function, we just want to find the highest y value of the function and the lowest y value of the function. So let's look at each of these interesting points that I made dots at of this function. So we see that there's one interesting point over here. It's the left end point of the function. The x value is negative 3, but the y value is 1, 2, 3, 4, 5, 6, 7. So the y value is is positive 7. So this point is located at negative 3, 7. We have another interesting point over here. We see the x value is negative 1, and the y value is 2. We have another point here, located at 1, 2, 3, 4, 1, 4. Another point down here located at 2, negative 3, and another point here located at about 3, 1. So looking at these y values, we have several y values that are of interest to us. We have y being 7, y being 2, y being 4, y being 1, and y being negative 3. The largest of those y values is 7. In fact, that's the largest value over this entire function. So the absolute max of this function is 7, and it's located at x equaling negative 3. And that's an important point to make here, that when we talk about extrema, we're talking about y values. So if I ask you to find the absolute maximum of a function, I'm asking you for the y value. So the absolute maximum of the function is 7. And adding this comment here that it's located at x equals negative 3 is only necessary if I ask for it. So similarly, the absolute minimum value of the function would be the lowest y value of the function, which is negative 3. The lowest point of the function is down here. So, and this is located, again, this is just more of a side note here, located at x equaling 2. So how does this compare to the relative or local extrema that we talked about before? Well, local extrema can't happen at the endpoints. They can only happen in between the endpoints of a function, because we need to have a neighborhood around those points. So just for comparison's sake, if we want to talk about the relative extrema, we have a relative min of 2 located at x equaling negative 1. That's this point right here. We also have another relative min over here of negative 3 at x equaling 2. And we also have a relative max of 4 over here, located at x equaling 1. So one thing you may notice is that we have more relative extrema than absolute extrema, and that's sometimes the case, it's not always, but they're not necessarily the same points. So here our relative max was 4, but our global max is 7, and that happens because, remember, relative extrema can only happen in between the function, over the inside of its domain. And there's always only one global max and global min. So even though we have two relative min, we only have one absolute min. And that does happen to match up with one of our relative min. So just plotting it, going point by point here, this first point on the left is a absolute or global max. The second point over here is a local min, or relative min, I should say. This next point here is a relative max, but not a global max. This next point is a relative min and the global min, or absolute min, of the function, so it's both. And this last point is a, well, it's nothing actually. There's nothing interesting about that last point. It's just an endpoint of the function. It's neither a relative max, nor a relative min, nor a global max, nor a global min. It's just a point along the function. All right, so let's talk about how to find these points. And it's relatively easy to find this graphically. But how do we actually find absolute maximums, absolute maxima and minima of a function? Well, to do this, there's a few points I want to make before we start off. First, it's on something called the extreme value theorem. The extreme value theorem states that a continuous function f is, if it's defined over a closed interval ab, then it must have an absolute max value and an absolute minimum value over ab. So that makes sense. So if we're drawing some continuous function and it's over a closed interval ab, so it has a starting point and an ending point of that function, then there has to be a highest point in the function and a lowest point of the function if that function is continuous, if there's no breaks in that function. This is called the extreme value theorem, and it's a very important theorem in mathematics and calculus. And from this, we can develop what's called the maximum minimum principle 1. So, simply put, the maximum minimum principle 1 states that if we have a function f and it's continuous, over a closed interval a to b, so a is just some number, b is just another number, we can find the absolute max and maximum min by just doing a few procedures. All we need to do is we need to look at the critical points and the endpoints, find the function values at those points, and the highest function value is going to be the absolute max, and the lowest function value is going to be the absolute min. So you're going to find your critical points using the first derivative, set it equal to 0, or find where it's undefined. So this is the same as the previous unit, how we found relative maximum and relative maxima and relative minimum. And we're just going to compare these values. So, so the absolute max will be the max of f of a, f of b, or f of any of the c values, any of the critical points. Ran out of space here. Basically, etc., however many critical points you have. Similarly, the absolute min will be the min of that list, the minimum value of that list. All right, so let's try to apply this principle. Let's do this by an example. All right. So let's find the absolute or global maximum and minimum values of the function f of x equals 1/3 x cubed minus 1/2 x squared minus 2x plus 1/3. And we're going to do this over the interval -2 to +4. So just for the sake of completeness or clarity, this -2 is our value for A, and this +4 is our value for B. So those are the endpoints. That's the closed interval we were just referring to. All right, so let's start off by finding our critical values, see if there are any critical values for this function. So let's find our critical values. So to find critical values, we just find the first derivative, then either set it to 0 or find where it's undefined. But since this is a polynomial function, it's not going to be undefined anywhere. So that makes this relatively easy, or easier. So we're just going to find the first derivative. I purposely picked a function here that it's kind of easy to find a derivative for. So let's see, 1/3 x cubed, you bring the 3 down. And 1/3 times 3 is just 1, so this just gives you x squared. Minus, let's see, 1/2 times 2x would just be x, minus 2 plus 0. So that's the first derivative. You set this equal to 0 to find the critical values. Okay, and then let's factor. And let's see, x minus 2 equals 0. That will happen when x is 2. And x plus 1 equals 0. That will happen when x is -1. So these are our critical values. Next, let's find our function values. At the left endpoint, the right endpoint, and all the critical values. So all the FFC values. It's a little confusing. So FFC1 and FFC2, because there's only 2 critical values. Okay, let's start off by plugging in the endpoints. So let's see, f of -2. If we do that, we get, and I used a calculator earlier, and I found that this was -1/3. Let's see, the rightmost endpoint, f of 4. Again, I used a calculator before, and I got this was 17/3. Or if you want, we could write it as a mixed number, 5 2/3. Or you could use decimals, and this would be approximately 5.67. It doesn't really matter. That's fine, too. We also want to find the f values at our critical points. So f of 2, again, I used a calculator earlier, and I found f of 2 was -3. And f of -1 will be 3/2 or 1.5, if you'd like to write it as a mixed number, or as a decimal, it would be 1.5. All right, so looking at this list, the absolute maximum is going to be the largest number in the mix. So this number here is the absolute max. And the absolute min is the lowest number in the list, which would be -3. And that's it. We're done. So just to write this a little bit neater, the absolute maximum of the function is the y value, so the f of x value of the function, so it's 5 2/3, located at x equaling 4. And the absolute minimum of the function is -3, located at x equaling 2.